Why is space dark even though there are millions of stars? Light, brightness, and illumination are all concepts that our minds naturally connect with daytime. When daylight hours arrive, we discover that the world around us is flooded with an incredible amount of light. Both the light on Earth's surface that reveals all its details to us and the light in the sky that allows us to see its features with remarkable clarity. We can see clouds as they move across the sky, watch flocks of birds soaring above, and even spot various objects like airplanes traveling through the atmosphere. The sky is brilliantly lit up, and if we ask ourselves what causes all this illumination, we'll find that the sun is behind it all. After the sun finishes its work and the Earth turns to give it its back, the scene changes completely. The light gradually disappears, transforming into darkness. If you try lifting your head to look at the sky, you'll find it's mostly black with just a few simple white dots, which raises a powerful question. How strange that when there was only one star, our sun, the whole world was bright and life was beautiful. Yet now, with millions upon millions of stars in a sky, space remains dark and almost completely dim. What's the secret? What makes a single star capable of illuminating this entire sky, while millions of other stars can't accomplish this task? What makes it so special? Our friend Tom built a new house. Due to the tough economic situation and his modest income as an employee, the house was just a single room measuring 4 meters by 4 meters. Tom decided to hang a bright lamp in the center of the room to provide enough light. The lamp worked perfectly for him, even better than expected, with its brightness being quite strong for such a small space. As time passed, he decided to change his job and work in a different field to start earning more money, since his current position wasn't cutting it financially. He actually made the switch and found a new job. The surprising part? He managed to make a lot more money in a short amount of time. The important thing is that Tom, as soon as he got the money, decided to expand his room and increase its space to 400 meters by 400 meters. For some reason, though, he didn't add any new lights to the room. He just kept using the single lamp that was already in the center of the original room, somehow expecting it to illuminate this enormous space for him. Now here's a question for you. Can this single light bulb really illuminate this entire space? Would the light reach all the way to the end of the room if you were standing there? And what if we expanded the room even more, making it 40,000 by 40,000 meters, or even 1 million? Do you think the light from this bulb could travel such a vast distance? Of course not. Does that help you understand the concept better? The lamp in the middle of the room represents stars, and the spacious room is like our vast universe. Space is incredibly huge, much bigger than Tom's room. But to be honest, that's not the only challenge we're facing. There's an even bigger problem. Tom isn't satisfied with just the room's current space. He's constantly trying to make the room bigger and bigger. Similarly, the universe has been expanding ever since it began more than 13.8 billion years ago. It remains in a continuous state of expansion. Due to this expansion, galaxies and stars are moving away from us, with the distance between us growing over time. This has a negative impact on the amount of light we receive from them. The light emitted from stars, or even the total light from an entire galaxy, must travel incredible distances through space to reach us, typically measured in millions of light years. And finally, after traveling all this incredible distance, the light reaches us completely exhausted, barely able to catch its breath. This might actually explain the mystery of why space appears dark despite the millions of stars out there. The truth is that outer space contains an astonishing number of stars, yet we still see darkness. Our Milky Way Galaxy alone contains nearly 200 billion stars just like our sun, and the universe has at least 100 billion galaxies at minimum. Multiply 100 billion galaxies by 200 billion stars, and logic suggests this massive number of stars should light up the entire universe. But as we can see, space is completely dark. Why is that? It's because these stars are constantly moving away from us, and the light traveling from them becomes extremely weak by the time it crosses the enormous distance between us. Add to that, stars in space aren't neatly arranged, but scattered randomly. Some areas have a high density of stars, while others are practically empty. This creates regions that are intensely bright, and others with no light at all, without any even distribution of stars, and with vast distances between them. So, are these the only factors that make space appear dark and mysterious? Or is there more to it? Actually, there's another powerful factor at play, and to understand it, we need to grasp how light travels. Try this. Go into your room, stand facing a wall, and shine a bright flashlight directly at it. What happens? You'll see that the wall becomes fully lit up. But notice something else. The other walls in the room also become illuminated. What if we removed that wall in front of you? Imagine it's replaced with empty space, but the light is still directed toward that area. Do you think any light would reach the room where you're standing? Of course not, and here's why. In the first case, you had an object in front of you reflecting light, which allowed you to detect the rays. But in the second case, there's nothing interrupting the path of light or reflecting its rays in that space. This is also exactly what happens in outer space. Space contains a vast emptiness that extends infinitely. When light leaves stars and goes on its way, it continues traveling for a long time without hitting anything. This is because most of space is simply void, and many celestial bodies are actually gaseous objects. Solid elements, or elements capable of reflecting light and showing its effect, are extremely rare and not abundant. As long as there's nothing to reflect light and make it visible, you won't sense its presence or influence. Therefore, all these combined factors ultimately cause space to appear as a dark, dim world, despite containing an enormous number of lamps. Okay, let's say we have a friend living in space. Let's call him Jimmy. Our buddy Jimmy can see both red light and infrared light. If we uploaded this video to his space version of YouTube, he'd be totally confused. He'd probably respond, "What on earth are you guys talking about? Dark space? Space isn't dark at all. From my perspective, space is perfectly bright and illuminated. There's light everywhere." Of course, we'd be baffled by this strange claim and say, "Jimmy, it seems like floating around in space has messed with your head. What glowing space are you talking about?" But in reality, Jimmy won't give up. He'll keep arguing and sticking to his idea. And of course, we're not going to give up either. We'll try to convince him that space is dark. I mean, we can't ignore what we're seeing with our own eyes. Besides, let's face it, we do enjoy a good argument. So what's going on here? Who's right, us or Jimmy? In reality, we both are. Space is dark, and space is also not dark and can be extremely bright. It all depends on how we see things and which light spectrums our eyes can detect. Remember that expansion concept we talked about at the beginning of the episode? That's what will solve our current dilemma. When space expands, it causes stars to move away from us, at astonishing speeds too. It's similar to someone holding a flashlight while walking backward, moving further away from us. True, they're still shining light in our direction, but they're getting more distant. So what does this have to do with whether space is dark or bright? Let me explain. There's an interesting physical reality at play here. When light-emitting objects like stars move farther away from us, their energy gradually decreases due to this increasing distance. As this light energy drops, its appearance shifts from the normal visible spectrum toward the red end of the color spectrum and its various shades. In fact, outer space contains enormous amounts of invisible light spectra. However, since the human eye can only see visible light and has no ability to detect infrared, ultraviolet, or other wavelengths beyond our visual range, space appears dark and empty to us. But if we have the ability to see any of these other spectra like our friend Jimmy does, we'd discover that space is actually incredibly bright all around us. From now until we develop the ability to somehow see invisible spectra, space will remain dark to our eyes. But let's not forget, this darkness isn't a bad thing at all. On the contrary, the darkness of space is exactly what highlights its beauty and reveals the intricate details of celestial bodies, planets, and stars within it. Not to mention, we wouldn't be able to sleep if everything was constantly illuminated. And with that, we've answered the question, why is space dark despite containing millions of stars? I hope you enjoyed the episode and found it helpful. See you next time when we explore another intriguing question.